My name is Kyoung-Sook Kim. I'm a senior researcher, Artificial Intelligence Research Center in AIST in Japan. So I would like to introduce one of project I am involved to related of the geospatial informations. So today, most of us we're talking about the 3D. So actually, in the context of the digital twins, we believe of the 3D map or geo information is a fundamental element to realize that. And so map is representative of the what and where it exists. And why we need a 3D map. So I don't want to talk about more detail, but anyway, we think the 3D map is to provide more accurate locations, and based on the accurate locations, we can provide safer and more secure mobilities. For example, the wheelchairs cases, if we cannot consider about the Z, and this we cannot support of their safety mobilities. Even the small, very small height of is tackled paving, but the wheelchair people, we heard the people on the wheelchair, they feel a little bit uncomfortable when they pass up this kind of blocks. So also we think if we created 3D maps, then we can develop the new generation of the geospatial map, such as the autonomous vehicle driving cars and robots, and also personal experience augmentation is not only the informations, and then also sustainable urban planning or disaster management. So those kind of new type of the geospatial services, we are very interested to create of the 3D map informations. However, depending on who is users, they need that different type of this 3D information, not only the geometric element, but also semantic features. For example, the car, they are mostly using the line strings element, but its drones, they are using the more pixelized map, and then also on the feature cases and also drone cases, they have different point of interest. Also, in this 3D map is not static informations. So in driving autonomous vehicles, they consider about local driving map to consider about the dynamic information from the sensor data, such as vehicles and people's movement. And then even indoor spaces, the traffic, pedestrian congestion map is helped to support of the efficient navigation or mobilities. But when we generated a 3D map from the large amount of low point 3D point cloud data or human mobility data obtained by the heterogeneous sensor devices, then we have the big issue to handle the big data. We face the big data problems. So it depending on the volumes, and also there are different sensors. So we have to also consider the variety and the variability and velocity and velocities. So those kind of issues is we need to handle it to consider about the 3D map. And then also, it is very, too expensive to manage and then construct a comprehensive and the highly accurate 3D geospatial informations by considering all type of the utilization in advance. So basically, compared to the 2D map, I think still we have a very big problem. We have some big obstacle to create of the 3D environment on the virtual side. That is because of the cost. So how can we reduce this kind of cost, this kind of motivations? 3 years ago, our organization started the project is one of the NEDO project. NEDO is our funding agency. So this project is a 3D map platform to support a safe and secure mobilities to realize an ecosystem of the 3D map platform that provides satisfactory of the 3D data set for supporting the various mobile services. So we inside of our project, we have 3 types of applications. For example, the human flow and the transportations, and then also logistics. And then to support these 3 types of the applications, we created of the data platform. Also, we are focused on the localization or detection position of the in not only the external environment but also internal environment. And also using the real spaces is such as the Odaiba and the Kashiawaha. This is the name of the place, and then we created of the real environment for our experiment. So I'm a sub-reading of this special temporary data platforms. And then our platform we called Point ML. So it's a place and time for the machine learning. So this platform is, we are considered about not only the static geospatial data, but also the dynamic geospatial data. So what is the static information is just like the wall or ceiling, those kind of, the buildings informations is we consider about as the static informations. And then dynamic information is, for example, the people's movement is or robot movement. Those kind of informations we also manage of the inside of our platform. So the platform can accumulate it and manage with a large amount of the real-time data of the moving pictures, such as the traveling vehicles data or flow of peoples, also analyzed to predict the congestion area given the time resolutions. And then our platform is quite big, have the big open software stacks. And then we support the 2 types of the API. One is the 3D API, map API, and then moving picture API. And then today I would like to show some demonstration of our applications. So first one is autonomous vehicles environment. So this maybe I'm gonna change this. So in this April, we attended some exhibition. It's called the Location Business Power in Japan. And this robot is autonomous driving the robots. And then in here, so you can see that there is a LiDAR sensors. And then this sensor is detected of the people's pose, orientations, also locations, and then try to tracking of the people's movement. And then also there is another LiDARs is also there have the same functionalities. And then those data is go to our platform via the API. And then our platforms continuously process of the which area have the more people where is the people's there how to say crowded. So you can see there's some red yellow box and the red box. So we represented this area is have more people than other area, and the red box is represented is more than 5 people in this area. So this is every 5 seconds they calculated of this kind of informations, and the platform accumulated of this information whole day, and the next day we make some deep learning model to predict of the conjunction informations. So in the left side, this information, this is kind of a prediction map of the conjunction using our DIM model. So you can see that some strong colors is represented is the we perfectly predict of the conjunction, and then some weak shell color is represented. This is still, we mispredicted. But anyway, this platform is hybrid, is the continuous query and then also batch query. And then another example is the workflow analysis, and then in a warehouse tour. And then this is the, I'm sorry for the, but this is the some warehouse information. And then we using the irregulars is picking information of the workers. We continuously generated of the movement information is like that. And then using the analyze the trajectory informations, we analyze of the which area people spend more time. So this graph represented of 3D, but this red color represented of the staying time. So you can see the which area is the workers, where the worker is spend more time than other place. So using this information, we can recommend of some optimization of the layout or scheduling of the pickings of the pickings. And then last demonstrations is the simulations. Using the simulation of the when we using the 3D map in the simulation, it is difficult to using the 3D point cloud data because of the volumes. So in usually simulation environment, they using the vector information or certain GIS models. But how can we create it of the 3D GIS model from the point cloud data? So for example, we can we capture the 3D point cloud data using the mobile equipment. So this is a mock-up environment of the living place in our buildings, and then we collected of the point cloud data, and then I think the network is a little bit have problem. So this is the example of the capturing the point cloud data, and then using our platform, we voxelize of this point cloud data, and then make the clean point cloud, the subset of the point cloud data. And then using the subset of the cloud data, we can try semantic segmentations, like the wall, we can try to recognize of the wall and ceilings, floors. And then using the certain Landsat algorithms, we created of the wall informations is like that. And then we can easily create a certain floor map information using our platforms. And then now we have the certain missions. How can we, it's not only work, how can we create it of the certain indoor model, GIS model? It's not only indoor but also the outdoor spaces. So currently we try to create it as a city GML, or we have a plan to create generated of the indoor GML. But anyway, so still we have a lot of the challenges to create it for the automatic generation, the 3D GIS model. So I'm very welcome to your collaborations or are interested. So please feel free to contact me. So thank you for your attention. I'm sorry I already did longer presentations.